Hi students, in this video we are going to prove that oscillation of a spring is simple harmonic, and also we are going to find out what is the time period of the simple harmonic motion of a spring. Okay, for that we are considering the case in which the spring is connected to a horizontal surface, which means spring is lying on a horizontal surface. So imagine a spring which is connected at one end to the wall and is lying on a horizontal surface, and a body of mass m attached to it. Okay. Now initially we are not applying any force on the spring, hence the spring is at rest, and this position is what we call the main position. We call it as x is equal to 0. Now let F be an amount of force applied in the spring to extend the spring. Okay, so we are applying an amount of force and we are extending the spring in the positive direction. Now what happens, as we are stretching the spring, a restoring force acts and it will try to bring the spring back to its initial position in the opposite direction, and this much is the displacement of the spring. Now what happens, we are stretching and we are releasing. So what happens, the restoring force tries to bring back the spring to its initial position, and instead of coming to rest at that initial position, the spring will go to the other side. It will get compressed, then again come back to initial position, go to the other side, and it keeps on moving to and fro. So we can say it is an example for oscillation, and in this video we are going to prove that such oscillations are simple harmonic. Okay, now this much is the displacement in the negative axis, and the restoring force will try to bring the spring back to the initial position, that is in this direction. This much is x. So we are going to find out, is such an oscillation an example for simple harmonic motion, and also what is the time period for in such a case. Okay, so restoring force. Acting the spring when it is displaced from mean position. Yes. F is equal to minus kx, where F is the restoring force, K is the spring factor, or we can call it as a force constant, and negative sign indicates that restoring force is the direction of, towards the main position. Now according to Newton's second law, we know F is equal to ma, which can be written as m into d square x by dt square. So comparing equation, these two equations, we can write m into d square x by dt square is equal to minus kx. Now what is actually k? Now omega square is k by m, or we can write k is equal to m omega square. So the above equation can be written as m into d square x by dt square. Instead of k, I am going to write m omega square x. This and this will get cancelled, m will get cancelled on both sides, and we can write acceleration d square x by dt square is equal to minus omega square x, where omega is the angular frequency and it is a constant, which means that acceleration of the spring d square x by dt square is proportional to the displacement, and negative sign indicates that it is directed towards the main position, which means motion or oscillation. What is oscillation of a spring is simple harmonic, and the motion is said to be simple harmonic motion. So we have proved that oscillation of a spring is simple harmonic. Next we are going to find out what is the time period for such an oscillation, or what is the time period for the oscillation of a spring. Time period. Now we know that angular frequency omega is 2 pi times the linear frequency, which can be written as 2 pi by t. So, or time period t is equal to 2 pi by omega. Now what is omega? We know omega square is k by m, or omega is root of k by m. So you can write time period t is equal to 2 pi root of m by k. This is the equation for time period for a spring. Thank you.